recording on Zoom. Okay. Yeah, now we're recording on Zoom. And I'm going to share my screen, show you the paper I'm working at. Screen number 2, share, and for Teams, screen number 2, share. Okay, now you can see my screen. That will be the example I'm going to talk about. But first, I'm going to explain how the coding for the case of the turning operation is working. So just a question, what will be the startup shape of the work part we are going to use in the turning operation? You remember that in the case of the milling, I can usually use a block shape. I can use even cylindrical shape can be milled. But in the case of the turning operation, because the part, as you can see in the photo behind me, the part is going to rotate by using the spindle. So usually the rotation required to have a symmetrical shape. Otherwise, we're going to have unbalance. We're going to have the shape, for example, this shape is going to be symmetrical, but in case we're going to have it offset from one side. At the high speed of the rotation, we're going to have a vibration. And this vibration is going to be too bad for the machine, for the cutting tool and the machine itself. So we always try to avoid having a non-symmetrical shape because this will cause a problem in the machining process. Now, the shape of the startup material is going to be a cylindrical shape. We call it the turning operation because the part will rotate. During its rotation, again, to put a cutting tool in one direction, set something. I'm sorry, okay. So we have the part is going to be a cylindrical shape. The part is rotating. Usually, it's going to be counterclockwise. And we are going to have the cutting tool coming in from one direction. Setting the depth of the cut, we are going to peel the part. Actually, we are peeling the part or shaving the part. So by, of course, it's going to be a single tip cutting tool, unlike the case of the milling operation. In contact, we are going to remove something like a seam wire away from one point. But as the cutting tool is moving in the direction of the feed rate, we're going to peel the whole part. So if this is the diameter of the work part D, this will be the center line of the work part, the center of the rotation. And we have another axis here. Now, we have to learn that everything rotating in the operation of the machining in general, not only turning, milling, and the drilling. This axis will be the z-axis. So this is my z-axis. The other axis is going to be the x-axis. So I can tell that this will be the positive x-axis, this will be the negative x-axis, and of course this will be my 0, 0 point. This will be the datum point. In the case of the milling operation. Now, some people setting the datum point to be the face. Some people set it to be the end. It's up to you to say whatever you want. But you have to mention that to the machinist before you're going to ask him to do the machining for you. Just imagine if this will be your datum point at the end there. So all the data you're going to give for the z-axis is going to be positive value. For the x-axis, if we're going to move in this direction, we're going to mention the diameter, not the radius. So we set the depth of the cut by mention what will be the diameter I will intend to cut. So for example, the diameter here is equal to 10 millimeters, just an example. And my next diameter I would like to have is going to be 8 millimeter. That means that the depth of the cut is equal to 1 millimeter. I have to write down in the code that the x is 10. Is 8. So actually I'm writing what will be the diameter I would like to have. So usually the part we're going to have from the turning operation is going to be, once again, symmetrical shape. Doesn't have to be cylindrical, but it's going to be symmetrical. That's means if I'm going to cut it, I will see that the upper half look like the the lower half. If I get to cut this part longwise, the shape I'm going to achieve is going to be a rectangular shape. This will be the center. This will be the datum point. This is the z-axis. And this is the x-axis. So this will be my 0, 0 point. Now you can see I don't have triple zero. I have only 2 zeros here because we have the x and the z. There's nothing for the y. The first is going to be the z, the x. The second is going to be the y. If I get to use this as a datum point, then everything going to move in this direction is going to be positive z. Everything after this point is going to be negative z. The spindle is hold the part by using the chuck. So as I told you that some people prefer to have this point, so you can see is exactly at the end of the chuck as a datum point. They think this will be much easier for them actually to have all the z value to be in positive instead of calculating in negative. It's a good point of view. So if I would like to shape a part, again, to have the square shape, and for example, my part is going to look like that. Okay, so what you can see here is I'm going to have line, and a 45-degree line, straight line, half circle, straight line. This will be copied on the other side. So that's mean the other side also will look like that because we are going to have a symmetry between the two shapes. To make this part, I only need to move the cutting, sorry for having too much vibration. Just need to move the cutting tool in one direction, and the thing will be printed down on the other side because this part is rotating. Or again, to actually scratch on my head. This is the part again to put the cutting tool here. So if I again to turn the thing, it will coming back from the other side. So it's going to be a full thing. Sorry for doing that. Don't do that at home. Now, we need to find out how we can remove that. Now, the turning operation has nothing to do with the milling operation when we use simply setting the depth of the cutting tool and move the cutting tool and remove the material. Because the cutting tool, once again, have a single tip in the case of the turning operation. We can now set it to a very high depth of the cut. The depth of the cut will be mainly depend on the cutting tool material we're using, the material we are cutting. So I cannot do the shaping like that. This will be the movement for the finishing operation only. And I need to peel the material layer by layer, and then again to have the approximate shape, and then again to finalize it by a continuous movement. Usually we're going to start from a certain point like this one. Usually we are going to move the cutting tool. Now let's consider that this will be my cutting tool. Okay, now this one is going to be left-handed because it's pointing to the left. Again, to move it from here to there to make my cut. This cutting tool, unfortunately, we're not going to be able to cut the circular shape. We have another cutting tool is going to be straight, and we have another cutting tool is going to be right-handed. It's depending on which direction the tip is showing at. So this will showing to the left, neutral, and toward the right. The one toward the right only can cut from the left to the right. The left inside side one is going to be cutting from the right to the left, and the one straight usually is going to be used to cut something like the circular shapes or make a group in the middle. So to cut this part, we need to have a multiple lines to do the job, layer by layer by layer. That means even for the circular shape, like that, it does have a radius. And I'm going to use this radius for the G02. Okay, so this will be the center. And we're going to move the cutting tool from here to here by using the G02. But I cannot do the cut direct like that when this one is built up. So what I need to remove is the first layer. I'm going to remove this part first. And I'm going to remove another layer. So I'm going to end up with doing the stepping thing. Third layer. Fourth. And the fifth. Well, I consider this one as fifth, but we can even make it less or more, depending on the radius we're going to have and the material we're going to cut. So I can decide what will be the depth of the cut. So we remove this layer first, moving from here. Okay, we set the depth of the cut to this point. Move it G01 to here. Then we go up, we go all the way here. We get down to the next depth of the cut, G01, go up, travel back, cut the third level, and the fourth level, and so on. So what I need to do in this case, I need to find the following points. I need to find point number 1, point number 2, point number 3, point number 4. I know this process is going to be quite lengthy. 4, 5, and this will be number 6, number 7, number 8, then number 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we're going to start from here, going to that depth, moving the cutting tool in this direction, again to reach that point. We leave the part we travel back to the next point, and we set the depth of the cut, G0 once again here, G00, G00, G01, G01, G00, and continuously until again to remove these layers. Most of the way we're going to use G01. We need some time to set up the value for the G54, G53, G72 for the caning and the other stuff. And that's what we're going to learn from the example we're going to see. Now, the useful website I found was this one. First, again, to share this website with you. It's contain description for all the where's the chat area here. It does have the codes, all the codes we have for digital coding. Just a second. Okay, that will be the first thing we're showing today. Another one is this one is quite, I think it's a protected one. But we're going to use this example, and we're going to explain the code for this one in today's session. We'll try to make it by hand. Actually, I'm not going to depend on the example we have here. Anyway, so this will be the examples page. I would like you to save this one on your computer because, especially the people on Teams, because we, sorry, on Zoom, because we may use it as we finish this tutorial. And this will be the other one. Okay, so this one is using the finish cut of G70. And once again, if you would like to remember what will be code we're using, you can simply go to the first link we use. It's contain all the codes we're using for the G-code. Now, what I'm going to start with is going to be the example here, but we're going to do it on our own way. So we will try actually to minimize that, and we will try to explain step by step. And again, you have the code here, and we're going to discuss line by line as we're going to compare it to what we have here. So basically, that's the part. What we can see here that this part is going to have 1, 2, 3 doubles. It does have 2 chamfers, 1 and 2, and no internal details. Now, for the internal details, we need to do something called the boring. And if you just remember that the boring process is opposite to the turning process. The only difference is that the turning is happening from the outside, while the boring is happening from the inside. I will explain that in very short way. And first, again, to create my cutting tool, I will consider that this is my cutting tool. That again to move it as well, again to do the cutting. And that will be for the turning operation. Okay, I'm going to use it to explain to you the diagrams we have on the left side. Well, let's do the turning first. I'm going to go to the boring later. So that's the shape. That means that the part we're going to start with is going to be just a cylindrical shape with a 70 millimeter diameter. I may explain that to you earlier in the manufacturing subject that how do you know how deep you go about that? Okay, the cutting tool material, the speed of the cutting, because this will increase the temperature, and the material I'm cutting. So if I'm going to cut, for example, wood, I can go down to 4 millimeters. That's possible. If I'm going to cut aluminium, maybe I need to go less than 2.5 millimeters. Let's say 2.5 millimeters. If I'm cutting steel, I will go anything below 2 millimeters. things will be different. If my cutting tool is carbide insert, I can go deeper than if I get to have the high-speed steel. First, because I can do the cut at faster rate, because the material is stronger. Does that answer your question, Vincent? Oh, by the way, Vincent's question was, how do we know the depth of the cut we're using? So this was the question. Okay, that's for the people who are watching the session on Zoom. Okay, so 70 millimeters. Just remember that usually we're going to use the diameter of the shaft again to start to work on. I need to look at what we have as standard shafts. Usually the standard shafts start with 5 millimeter diameter, and then we're going to have 10 millimeter diameter, 15, 20, 25, then 30. After the 30, the figures start to jump by tens. So it's going to be 40 millimeter, 50 millimeter, and 60 up to 100. After 100, usually we're going to jump to 150, then 200, 300, 250, 300, and so on. The standardization coming because we cannot actually make the bars to a costume diameter. That's mean if your job required to have the maximum diameter here to be 58, you cannot make your bar with the standard diameter of 58. You need to take 60 and remove 1 millimeter from one side as depth of the cut, and this will reduce the diameter by 2 millimeters. Now, if I get to take a look to the cross section of the cylindrical shape, is going to be a rectangular shape like that, well, the black box. So you can see that this is the black box. The black box here represent the cross section of the cylindrical shape. We define the datum point. This can be here, as we mentioned at the beginning, or it can be here as the face of the chuck. This axis is the z-axis. Actually, is going to be y's. I'm going to sketch here. Oops. And all the way down. Oh, sorry. So. Okay, so this will be the x-axis, this will be the z-axis. Now, if I'm going to choose that point as my datum point, then everything going to the right side after this blue point is going to be a positive z value. Everything going to the left after the blue point is going to be a negative z value. To start the cut, we need just to remove a very thin layer from the top. And that's what defined by the red line. So to do that, and actually usually you need to remove a face layer here as well. Because usually when you cut the bar, you're going to cut it with the saw. And when you cut it with the saw, the shape of the face is not going to be regular. So we need to remove some of the material. So usually the movement of the cutting tool is going to start from any point in this face. We take it down, coming to here. We insert a certain depth of the cut. For example, if the datum point is at the face of the finished work part, and we add something about 1 millimeter at the face, again to insert the cutting tool to the value where the Z is equal to 0. And the X is equal to the diameter, which is 70 millimeters. And then I'm going to say G01 to the X is equal to 0. So the cutting tool will simply going to remove a layer from the work part. Going to the center is actually going to mean that the whole face has been cut, because once again, the part is rotating. So now I cleaned the face. I set the length of the work part exactly as I wanted. Now we travel back and then we go up again. And now we are going to start the process of the shaping of the work part to reduce the diameter. So again, to go with the G00, going to that point. And this point is going to be, we said that the diameter now is 70. I'm going to send it to the X is, let's say 70. And the Z is equal to 2 millimeters positive. Then my work is going to be as following. G01, let's see what is the length of the work part. We're talking about 30 plus 25 plus 45, which is equal to 100 in total. That's mean my code here from this point to this point is going to be G01 to the Z equal to minus 100. Now we're cutting to here. I cannot go back while touching the part. So I need to take off the cutting tool back, G00 to that point in the space, then G00 to the back. Okay, now I'm at this position. Now I need to clear this area. I'm going to clear it to be step by step, have a stable shape, then I'm going to cut the chamfer and cut the cylindrical shape. So we go to the next shape and see what will be the next movement we're going to have to achieve the shape cutting. So we said now we are standing here. We're going to go down to the new diameter. This 170, I'm going to take it to the next diameter of 60. Well, this one is, I remember it was 60. Actually, I'm doing a wrong thing. Yeah, 60. So I'm going to do the next cut to be 68. 68, that means it's 1 millimeter. So again, to take it further for another 1 millimeter, again, to make it as 66. So the depth of the cut here is 2 millimeter. 66, the cutting tool is here. Then again, to send it as G01 to that point here. So I removed a layer. Travel back out of the work part, travel back to this position. Then I will need to go down to a deeper layer. So let's see what we have on the other shape. Okay, so we went back to this point and shaved another layer. Then we left the part out, going back to this position, again to go to another depth, and we continue doing that until we're going to have a shape with the lines like this one. So what we've done here is multiple going forward and backward, removing a layer after layer, until we are going to have primarily shape of the work part, what is going to be stepped here instead of having the chamfer shape. Even here is going to be stepped. So after we're doing that, okay, after we're doing the last cut here, we can simply go up. Then we go down all the way down to here. Set a depth of the cut of 0.25 millimeter. That's for the finishing. Increase the RPM. and move the cutting tool slowly to finalize the cut. Up, chamfer down, and then leave the part and turn off the code. Now, I think that we explained that earlier in the manufacturing subject. Are you confused here, or do you think this will be a simple thing? The only thing you need to do now is every time you sketch a tool path, you need to find the points that the cutting tool tip is going to be moving between. So we're starting from here, we're going to here, so we need this point. So we can write down the G00 to this position. And G01, you have to put the value for the Z and this position. G00, the X and the Z here. G00, you know this point already. G0 to the next level, the X value will be changed. G01, go back, G00, G00, G01 to that position. Okay, until again to finish the work. Now, the depth of the cut here, as we mentioned earlier, will depend on the cutting tool material and the material we cut. And it's usually wiser to, if you would like to have a good surface finishing, to use less depth of the cut each time. But the problem we're going to have here that this will take the cutting time to be longer than what we want to have. Question before again to move forward. Like to read the code we have on the website. Any questions here?
Oh, good. Thank you, sir. Oh, good.
Great. Great. Okay. Now we are going to check the examples we have on the website here. Let's go to the example. Okay. So now you can see that the code is going to start as following. First, the first number we have here, which is 002. This will be the code number. You are going to set up this one. You can see that this one doesn't start with the N or line number. Doesn't start with the code like the M or the G. This will give you the code number. It's 4-digit number with a symbol, and this will be saved on the machine. Usually all the machines can save up to, according to the memory, but most of them can save 9,999 codes. You can recall it each time. So you don't have to write down the code every time. You don't need to upload the code every time. You only need to store it in the memory. And whenever you're going to make the same part again, you can call this number and use it. The first line we're going to have is N10, G50. The spindle speed is going to be 2000 RPM. The tool we use is number 0100. G96, the S is 180, and the M03. Now, can you tell me why we have here 2000 and why we have here as 180? I'm not going to examine you here, but if you have any code that you don't understand, just go to this page I shared with you. G50 is the maximum spindle speed. This is all scale to 1. This will be the maximum speed we can have. Now, the G, which was the other G, sorry. 96 constant surface speed. So we're going to have 180 for all the process. M03, that means that spindle must work. Now, check last time when we were doing the tutorial about the question he asked me. He forgot to put the M03. If you don't put the M03, the cutting tool will start to move where there's no movement. I mean, there's no rotation. In the case of the turning, if you're going to make the process without putting the M03, the cutting tool will hit the work part, does not rotate, and will break up suddenly. The same thing will happen in the case of the milling. If the cutting tool is not rotating and is going to hit the work part, it will break. So just remember that it's going to be a good idea to run the code without work part at the beginning, just to check the movement. Just check that the spindle is rotating before you're going to upload the work part. Now, the next code is G00 to the X is equal 70.5. Z is equal to 5, using the tool of the 101 and use the M08. M08, if you don't remember what's that, this is the coolant on. Usually when you do a cutting operation, you are going to use the coolant fluid to dissipate the heat. You don't want the cutting tool to be heated up or the work part to be heated up. Now, what we did here when we went to the point, that's the X is 70.5 and the Z is 5, that means we are here. It's on this direction for the Z, positive value, a little bit above the work part by 0.25 millimeters. When I say 0.25 millimeters, because I'm going to add here 0.25, it's going to be added on the other side as 0.25, and this will make it as the 70 millimeter in diameter. So just remember once again here, we're using the diameter as the X value, not the radius. So it's 70.5, Z is 5, that means it's going to be on the right side of the datum point, which is located on the face of the work part. Now next point is G01, go to the Z equal to -1. That means that my cutting tool is going to move from this side of the point 00 to that side by the depth of 1 millimeter negative. Okay, and the feed rate we're going to use is going to be 0.25 millimeter per revolution. So the only thing happening is that my cutting tool is moving down, moving in this direction, sorry. It's going to move in this direction. Then I'm going to use the U2, Z equal to 0.5. Okay, that's just retreat by 2 millimeters to the outside. Then G01, go to the X is equal to -1.6 with the feed rate of 0.23. That's means my cutting tool is going to go to the 0 first, then it's going to pass it a little bit. So we're not going to have this small pin in the center of the work part that has been finished by facing. Okay, so that's why we had the value here for the X is in negative value. Now G00 going to the X is equal to 65. W is equal to 1. That's when we are going to retreat back where the diameter is equal to 65, which will be here. And then G01 going to the Z equal to -54. So we're going beyond the 0 point by -54 millimeters, 54.5 actually. And we set the feed rate once again. Now you can see that the feed rate is going to be different if we're going to move along the X-axis or along the Z-axis. This will be a different value. Usually it's going to be higher than the one we're using for the face milling. Now we are going to go back to the point number 2, z is equal to 1. So we need to go back. Then we set the depth of the cut a little bit further by another 2.5 millimeters from 65 to 60. That means the depth of the cut is equal to delta D divided by 2, which is 2.5. Okay, then go to the depth of 54.5. So we keep doing that, going forward and backward, until we are going to achieve the final diameter we are going to have, which was 230. Let's see when it's going to reach 30. I'm sorry, 50. 50. Okay, where did we got the x is 50? So, okay, now this is the x is equal to 50.5. That means it's leaving 0.25 millimeters for the finish cutting. Okay, now going to the G01 to the z is equal to minus 30, then go to the x is equal to 30, z equal to minus 54.7. That's just even up. Going to up to the x equal to 72, and G00 to the x equal to 150. That's been too high, away from the work part. Z equal to 200, and change the tool. M01. Then we start to write down another code. Now this code mainly is going to be for the finishing, make the chamfering and do the other part. So this can be considered form here. After the M01, let's check what the M01 code is. Option is stop, operator selected to enable. So it's something like we're going to go for the subroutine to finishing the code. Okay, so M01, then we start write down a new code. N20, G50, S2300, and the tool is number 300. G96, the S is going to be running at 200 RPM, and the M03, that means the spindle will start to work. Now we can see that we're going to the X is equal to 55.5, and Z is equal to 5. Turn on the coolant. Go to the Z is equal to 0, just attach it to the face. G01, X is equal to minus 1.6. Just remember when we finish the facing act. The feed rate is 0.2 millimeter per revolution. G00 to the X is equal to 46 after we're finishing the whole facing again. Okay, we go up. Z is equal to 3. G42, Z is equal to 1. G01 going to the diameter of X is equal to 50. The depth of the cut we are going to have on the face along the z-axis is minus 1, with the feed rate of 0.15. Move to the z is equal to minus 30, which is the first level. Okay, so we just clean this area. Now we're going to move from this point to that point. Then from this point up to here. From this point, we are going to have the chamfering here. And finally, we are going to move to the point where the z is equal to minus 100 before we are going to finish the work. After that, G40, U2, W1, and we are going to finish with the code, and that's it. Now, did anyone ask himself what the U and W is referring to?
Yeah, but I didn't know.
Okay, now the U and the W is something similar to the I and the J we used to have in the case of the milling operation. Okay, I think that's mentioned somewhere here, but that's what we use in the case of the milling operation. We just playing with this code, but it's not that popular actually. It's not used too much. First, you can see that always we're going to use it in the case of the G40, which is the compensation of the cutting tool. Now, when we are going to use this compensation, have you ever seen the carbide insert cutting tool, the one with the diamond shape? Have you seen the carbide insert cutting tool?
No, sir.
Okay, I'm going to show you one, and I'm going to show you what will be the W and the U will help you to do so. I told you this will be something similar to the I and the J. Carbide cutting, cutting inserts. Okay, I got one. Okay, now you can see that in the carbide insert, usually the edges here is not a tip, it's not a needle. It's always going to have a radius. And maybe we can see that better in the case of the images. Okay, you can see that we have a radius here. So this radius is going to have a center. And the G40 is going to, why we start to have too many ads here. Yep, so the G40 is going to offset this center away from the line of the cutting. So the W and the U and the W actually, is going to locate what will be the location of this center from the work part. So just push it away by the distance of the U in the x-axis and W in the z-axis. So it's something like it turns, as I told you, like the one we had in the case of the I and the J. That will be for the compensation, tool cutter compensation off, and this will be on. Okay, and usually we're going to use that in the case of the finishing operation because this will be very important to have the exact dimension for the work part. Okay, so just remember that once again, that the value for the U and the W is going to be the amount of the offset we're going to have for the cutting tool radius center from the work part. So G40 has been turned off, and the G41 actually, or 42 has been, where's G41? Was somewhere here, has activated the thing. We do have multiple examples. Now this one is going to have a radius, and this will make the process a little bit more challenging, but I can actually show you the example. But first, let's take a look about this part. I don't know if we have any of the students here who did the advanced manufacturing and they did the work for the chess part. I think David on Zoom. David, have you done the practical work for the advanced manufacturing? Oh, you did the CNC milling. So David did the CNC milling, but half of the student did the turning operation. So what we had, they had to do something similar to that, but we did with the CAD CAM. I'm going to show you that once again on how the process is happening. So once again, you will see that I know that you cannot hear the voice because I didn't share the voice, but this will give you an approximate. Okay, so you can see that we start to remove layer by layer. We never go for the whole depth in one shot. This will put a lot of force on the cutting tool. So you can see that this shape is going to be stepped. And now we're going to have the finishing operation to remove this stipple shape and have it as a full curve. Now this one is turned machine. In turned machine, you can change your cutting tool to be left-handed or right-handed according to your work. So that was the part that the student used to cut in the advanced manufacturing. Mainly that's happened back in 2019, 18 and 19. That's the facing operation, the face cutting. So you will see that actually it didn't went to the end. There's no face full facing. This machine is called turning and milling operation because both operation can be done with this single setup. I don't know what is an engraving on the other side, but it's doing now an engraving. You can tell that from the cutting tool, something like and to write down something. Okay, now this will be a boring operation, which is making an internal hole. And I'm going to explain that to you and how okay, now this will be the tool for the boring operation. The boring is the process of enlarging an existing hole. That means you need to drill first, and then you're going to do the cutting like this one, which is going to be something like enlarging. So it's going to be opposite to the turning. Turning is reducing diameter from the outside. The boring is increasing the diameter from the inside. That's nice work. Actually, my people hadn't do the whole work. Now, this is the cooling fluid we talked about. So, cutting with the saw. Okay, now you can see this will be the shape we're going to achieve from the cutting by the saw. And what I'm going to do is just single facing operation. It will go to the center and beyond. Let's go to the center, where it's going to be the x the 0, but it's went a little bit further, and we're going to have the part. Okay, I hope that this one make you like the turning. Actually, I like the turning more than the milling because we can do an exciting shape with it. Anyway, so now let's have an example that contain the process of using the G02. Now you can see that this part can be a good exercise for you. You can see that the number of the caning codes we have in here, but these codes actually not going to generate the primarily shape before we're going to have the finishing operation. I mean, you cannot start cutting like that. What you need to do is first you need to shave and peel off the part and make it as a silver shape before you're going to do this operation or this movement to generate the final shape. In this one, we have one arc here. And this arc is going to move from this point to that point. The only you need to do is that you need to know what will be the radius here, the location of this point, and location of that point. Location of that point because you are going to move to it from here to here. Then you write down G02, put the X and Z value of that point, and put the R at the end. Okay, put the R at the end. I think that in the code we're going to see below, they're going to put the I and the J, but it still can't put the R. It's going to be much easier to figure out. So you can see that this code is quite short because mainly is going to, as I said, it's just making these lines that represent nothing. Your exercise is write down the full code to peel off the part first, make it as a stipple shape, and then you are going to finish it. When you finish this code, I would like you to run it on the same simulator we shared last Monday. I have another tutorial for the same simulator, but for the turning operation. I'm going to share that with you, and I think I can share it with you now. Just give me 1 second. Just let me find it. This will help a lot. How many people here did try to use the simulator? Because at least I talked to 3 people who asked me about the simulator, and they were using proficiently, which is actually, I like it. I hope the other people also try to do something. I know that maybe you're busy or enjoying the holiday. By the way, I'm really happy for the results you got for your manufacturing and the advanced manufacturing. The advanced manufacturing. I'm really proud about your achievement, and I hope you will keep on doing this good work. Okay, so yeah, so this will be the tutorial we have for the simulator for the case of the milling operation, turning operation. So I'm going to why this one is here. Okay, so this will be the link. I'm going to share this one here, and also I'm going to put this one on LinkedIn for the student who using the Zoom, so they can find it. Okay, so this will show you step by step on how to choose the work part, how to define the datum point, and end up with entering the code. I remember I just put a simple code here. Okay, and then it's going to run it. Again, I think that this simulator is going to be a very interesting thing. It's going to enrich your information about how to put the code on the machine, because that's what we're doing right here. And also is going to be a good device to check your code before you're going to load it on the actual machine. By the way, you can save the code and upload it directly to the machine by using a USB. Of course, you can use the same computer for both operations. This will be a good thing. Yeah, I'm running the thing step by step. So they're just an example. How to increase the velocity? Yeah, as I told you, I think that this tutorial was very simple, just to show you how to put the part and then how to insert the code and start to write. I'm running things step by step. Now I think that here you can make the. Did I put anything with the G02? No, but anyway. Oh yeah. I think that's G02. But the problem is that the face doesn't look very good. I don't know if the card I'm using in my computer is not that good. Okay, so we will start with this one. As I told you, your exercise is going to be the second example we have in here. Take these dimensions, put on paper, find the points that the cutting tool needs to move to make the shaping step by step, and then at the end, write down the finishing code, which is start the work from the top to the center, or from the center to the top is up to you. Then moving all the way down, cutting the chamfer, cutting straight, cutting with the G02, you can find the radius here is 20 millimeter. And you go up and chamfer once again and straight line for the finishing operation. Use the depth of the cut here to be something about 2 millimeter for the roughing and 0.25 millimeter for the finishing. Do you think that you can take this challenge? It shouldn't be hard. As I told you, it's just 2 dimensions.
It should be all right.
Should be all right. Yep. Okay. So on Monday, we're going to start with the CAD/CAM, but it's going to be nice if you are going to do a work, if you're going to write the code and put on the simulator, make a video and put it on the team group. Okay, so share your experience. Let us know what you're doing. Okay, guys? So I don't want to take your time. It's already 7 o'clock, and I hope that, well, I don't want to be heavy because actually that was one of the things that I lost points of in the SFS this semester. I don't know why many people didn't like the process of having an extra sessions. So actually what I got with the advanced manufacturing was good, but it cannot be compared to the last year when I got 4.95, I got only 4.62. But the problem I had was with the manufacturing. I don't know why many people didn't like what happened. I don't know. I wasn't that bad, but I got something about 4.3 or 4.28. Usually I got 4.7 for this subject. Anyway, maybe next year we can fix the thing. Okay, so I'm going to stop here. Thank you very much. And I hope that you enjoyed today's session. We learned new experience. On Monday, we're going to learn about the CAD/CAM. I'll try to teach myself on the free CAD/CAM. So you don't have to stuck with the UTS resources. You can use your, you can download the free CAD/CAM maybe and start to use it. You can make your own profile on LinkedIn, for example, and show the people what you can do. This will help you a lot. Also, you can put it on your resume. You can start put these things in your resume as long as you achieved the simulation of the exercise we had last week and the one we're going to do right now. And you can say that you have the principle of the G coding programming. And this will help you a lot actually to find internships and even jobs in the future. Thank you very much again to stop the report here. And once again, if you have any question, again, to be more than happy to answer you.